We're now going to introduce you to de Moivre's theorem. De Moivre's theorem in its most basic form is a theorem that provides us with a means for raising a complex number to a positive integer power. Let's see what it says. If z equals r times the cosine of theta plus I sine of theta is a complex number, then z to the n power equals r to the n power times the cosine of n theta plus I times the sine of n theta, where n greater than or equal to 1 is a positive integer. So let's look at an example where here I'm taking 2 times the cosine of 20 degrees plus I sine 20 degrees and raising it to the third power. So what the theorem states is that I take the magnitude 2 and raise it to the third power. So we get 2 cubed. Then I take the arguments of each of the trig functions and multiply them by the exponent. So that's going to be 3 times 20 degrees plus I times the sine of 3 times 20 degrees. So 2 cubed is 8. And then I have cosine of 60 degrees plus I times the sine of 60 degrees. The cosine of 60 degrees is, of course, 1/2. The sine of 60 degrees is the square root of 3 over 2. After distributing the 8, we get 8 times 1/2 is 4, plus 8, then divided by this 2 is going to give me 4 root 3, and then I. So I've taken this complex number and raised it to the third power, and the result is 4 plus 4 times the square root of 3, I.